Imagine it's a Tuesday. You're looking up at the night sky, and for the first time in human history, the North Star isn't the brightest thing in the heavens. Instead, there's a flickering, angry violet light pulsing from the direction of the red planet. You aren't watching a natural phenomenon. You're watching the birth of a new world, delivered by the fire of 10,000 suns. Since the dawn of the space age, we've looked at Mars and seen a graveyard, a cold, irradiated desert where life goes to die. It is a world of no air, no heat, no liquid water, no hope. But what if the key to breathing life back into this dead world was the very thing we fear most on our own? It sounds like a supervillain's plot, a madness born of high-concept science fiction. But this isn't a movie. It's a real proposal, backed by some of the most ambitious and perhaps most dangerous minds on Earth. The plan? Project Prometheus. The goal? Detonate a relentless, years-long barrage of high-yield thermonuclear warheads over the Martian poles to create a series of artificial suns. Today, we're going beyond the do not enter signs of planetary physics. We're exploring the catastrophic, the visionary, and the terrifying reality of nuking Mars. Is it the ultimate shortcut to a second home, or are we just planning to murder a planet for the second time? To understand why we'd even consider nuking Mars, you have to understand the sheer brutality of the Martian environment. It isn't just chilly. It's a thermal prison. On a warm summer day at the equator, it might hit 20 degrees Celsius, but the moment the sun dips, it plunges to negative 73 degrees Celsius. At the poles, you're looking at negative 150 degrees Celsius. But the cold isn't the real killer. It's the pressure, or the total lack of it. On Earth, the weight of the atmosphere, about 14.7 pounds per square inch, keeps our liquid water from boiling away. On Mars, the atmosphere is 100 times thinner than ours. It's a near vacuum. If you stood on the surface without a pressurized suit, you wouldn't just freeze. The physics would turn against your own body. The saliva on your tongue, the moisture in your eyes, and the very fluids in your lungs would literally boil at room temperature. You would die of dehydration and suffocation simultaneously, while your blood turned to foam. Mars is currently trapped in what scientists call a low-temperature equilibrium. It's a frozen ball of carbon dioxide and water ice, locked in a cycle of death. The big idea, popularized by figures like Elon Musk and studied by researchers at the University of Colorado, is that if we can just kickstart the temperature, we can trigger a runaway greenhouse effect. We don't need to heat the whole planet ourselves, we just need to tip the first domino. But that domino is heavy, really heavy. To melt the Martian ice caps, we need an astronomical amount of energy. We are talking about approximately 10 to the 21 joules. To put that in perspective, the Tsar Bomba, the most powerful nuclear weapon ever detonated, released about 2.1 times 10 to the 17 joules. To get the job done, we wouldn't just need one bomb. We'd need a literal pulse of artificial suns, thousands of warheads flickering over the poles every few seconds for weeks, months, or even years. Close your eyes and picture the silence of the Martian North Pole. For 4 billion years, the only sound here has been the whistle of thin, CO2-laden wind. Then, the brakes. A fleet of automated starships, the greatest armada in human history, arrives in low Martian orbit. They aren't carrying colonists, they're carrying the teeth of the Cold War. The first warhead drops. It doesn't hit the ground. A ground strike would be a disaster. It would kick up dust, block the sun, and cause a nuclear winter, making Mars even colder. No, this bomb is a high-altitude burst. At 30 miles above the ice cap, the timer hits 0. For a microsecond, there is a point of light brighter than 1,000 Earth suns. In a vacuum, there is no sound, just a violent, invisible wave of gamma rays and X-rays slamming into the atmosphere. The fireball isn't a cloud of smoke,
It's a sphere of pure incandescent plasma. The radiation hits the frozen CO2 ice below. On the ground, the ice doesn't melt, it sublimes. It turns instantly from a solid to a gas in a process so violent it creates its own weather system. A massive plume of carbon dioxide erupts into the sky, thickening the air in real time. Then comes the second bomb, then the third, a rhythmic, terrifying heartbeat of fusion. From the surface of Mars, the sky isn't blue or pink anymore. It's a strobing, violet hellscape. Each explosion adds more gas, more pressure, and more heat. This is the artificial sun theory. By keeping a constant chain of explosions going, we mimic the heat of a star directly above the poles. The ice caps, which contain enough CO2 to potentially double or triple the atmospheric pressure of Mars, begin to vanish. If it works, the feedback loop takes over. As the CO2 enters the atmosphere, it traps the sun's natural heat. The planet warms, melting more ice, releasing more gas, which warms the planet further. In this scenario, we are not the ones terraforming Mars. Physics is. In a few decades, the atmospheric pressure could rise to the point where the boiling blood problem disappears. You could walk outside with just an oxygen mask and a heavy parka. You could see clouds. You might even see the first rain in 3 billion years. But science isn't a Hollywood ending, and the Nuke Mars plan has a dark, irradiated underbelly that most futurists don't want to talk about. First, there's the radioactive problem. Proponents argue that we can use clean fusion bombs, devices that rely on hydrogen fusion rather than heavy uranium fission. But clean is a relative term in nuclear physics. Even the cleanest bomb produces secondary radiation. We'd be raining cesium-137 and strontium-90 down on the very soil we hope to one day farm. We might create a blue Mars, but it would be a glow-in-the-dark Mars. Imagine the first Martian colony having to deal with soil that is more toxic than the basement of Chernobyl. Then there's the ethics of planetary vandalism. We assume Mars is dead because we haven't seen anything moving on the surface. But what if we're wrong? What if there are extremophiles, microbes hiding in the deep brine beneath the ice? By nuking the poles, we're not just terraforming, we're committing planetary-scale genocide before we've even had the chance to say hello. We would be destroying the greatest scientific library in the solar system, the history of alien life, just so we can have a slightly shorter commute to a second home. And finally, the physics might just fail. NASA's 2018 study suggested that even if we nuked every square inch of the Martian poles, there simply isn't enough CO2 left on the planet to reach the pressure levels we need. Most of Mars's atmosphere didn't freeze, it escaped into space billions of years ago because Mars lacks a magnetic field. We could detonate our entire global nuclear stockpile, turn the planet into a radioactive wasteland, and find out at the end that the needle barely moved. We'd be left with a world that is still freezing, still dead, but now also lethal to touch. So why does this idea persist? Why do we keep talking about nuking our neighbor? Because humanity is a species of extremes. We're the children of the frontier. We've reached the point where our technology has outpaced our wisdom, and we're itching to use our God powers. Nuking Mars is the ultimate Hail Mary. It represents our refusal to accept that some worlds might be closed to us. It's the ultimate expression of the Promethean spirit, the myth of the Titan who stole fire from the gods to give it to humanity. But remember how that story ended. Prometheus was chained to a rock for eternity for his hubris. Will we ever actually do it? Probably not with nukes. The political fallout on Earth alone would be enough to stop any launch. Giant orbital mirrors that reflect sunlight or the release of super greenhouse gases like CFCs are far more likely. They are slower, safer, and less explosive. But the fact that we're even having this conversation proves one thing. We're no longer just observers of the universe, we're its architects. We're the first generation in the history of life on Earth that has the power to decide the fate of another world. We have to ask ourselves, Are we the gardeners of the galaxy, carefully tending to the seeds of life? Or are we the wrecking ball, smashing everything in our path to build a monument to our own ego? Mars is waiting. It's cold, it's silent, and it's red. For now. Whether it stays that way, or whether we turn it into a sun-scorched, radioactive workshop for a new humanity, is entirely up to us. The countdown has already begun. The only question is, do we really want to pull the trigger?